First of all, everybody, good morning. We went over a lot the last couple of weeks, and some of it may seem very basic, but as you can see, it's starting to build up to practical applications of what's on site. Okay, we went through some drawings last week. I hope some of you would have taken the time at your job site to look at the drawings, look at how they apply to what's built, and make sure you understand the correlation between the two. What I wanted to do this week is I wanted to expand a little bit on a conversation we had last week regarding architectural drawings. Okay? We went through a lot, and at a lot of points, I made comments that these dimensions may or may not hold, and that it's based on the shop drawings from manufacturers. In front of you, you should have a few sets of shop drawings. You should have one for windows and doors, and you should have a millwork shop drawing for cabinetry for a kitchen. I bring these two out specifically for a reason. The architect who's drawing this job, working with the structural engineer to give you your layouts, is working off of a, let's call it a generic profile. Every window manufacturer, as we said last week, has an NOA, a notice of acceptance. That means for the manufacturer who's providing the windows or doors, they have a approved method of installation, which means it's been tested and approved for impact rating, for hurricane rating. And with that, you use a certain screw, you use a certain method. That window is what's really going to determine, and that NOA is really going to determine your openings. It's really going to determine how you prepare for that window. So if you look, start with this, okay? This is a shop drawing, maybe the colored one, for the front door of one of our projects, okay? Every shop drawing is going to give you the details about what the product is. In this case, it's telling you that it's an aluminum pivot door by Windor. It's telling you what the finish is, Bermuda, bronze, Kynar finish. It's telling you what the glass is. It's telling you what the hardware is. And then it's giving you details about how it's installed. You can see here, okay? In this case, it's giving you the details about a buck, a shim, and it's also using a couple of terms you guys should know. MO stands for masonry opening. Okay? FS stands for frame size. Okay, so what this is doing is saying for this manufacturer, this is what's required to put this door in. These are the guidelines you follow when you're preparing this opening with the shell contractor. Now in this case, the opening was done before the door was ordered or selected. So you'll see it says existing MO, and then it says new MO, because the opening had to be modified once the detail was finalized. So it's important that when you look at things like this, you realize that it's based on the manufacturer's cuts. It's kind of like if you were buying a car. If you buy a Chevy, you buy a Ford, they're not the same car. If you buy a window, from whether it be Velocity or, in this case, Windor or whatever else, each manufacturer has their individual testing and their individual standards, okay? There's a series of shop drawings that go with windows, with doors. This is just an example of how you have to correlate your shell contractor's work, guys making the openings in block or concrete, with the actual window going in. Now, I bring this up in the next one for a reason. If you look at the next one, this is a kitchen layout, okay? This is a layout by one of our millwork contractors for a kitchen. And it's set up in pretty much the same way. Gives you the material, the finishes, the sizes. If you look under drawings on the right-hand side, it will also show you the revision dates, meaning that this is not the first drawing. This is the third drawing after it's been revised. If you go through it, you'll see comments from the architect that are in red. Okay. These drawings are made so that you can ensure this works with the opening you have. And I'll go through that in a second, okay? So you're on a job, you've done your shell, you've put your windows in, okay? Everything's in. Now you're laying out your kitchen. You have a set dimension that you now have to work to make this kitchen fit. And this goes back to Dan's question the other day. What happens if you don't have a wall location or a size, right? In this particular kitchen, the layout from the architect was a little bit off, okay? So where everything has to be centered, in other words, if you go to the page 4, you'll see the elevation of the wall that has the stove, okay? This wall now has to be equal, the stove center and the windows equal on both sides. The cabinet returns on both sides have to line up to the window. Do you see that? What that means is those windows are already installed. You have to make whatever adjustments you have to make on site so that all these lay out. The stove does line up center. You don't wind up with 3/4 of an inch to a window on one side and 1/4 on the other. So in this particular job, what we had to do is, if you look all the way on the left on that drawing, you'll see a 6-inch wall. Okay? We had to make modifications during the layout so that this stove was centered on these windows and centered on this room. Okay? All this you try to lay out before you frame. And you have to look at what the impact of whatever changes you make are. Okay? During the process, you have the ability to shift the window slightly within a masonry opening. Right? The NOA will say you need a 1-inch buck or a 2-inch buck. It'll give you some variations of what you could do. You could shim that window left or right, but you can't do it after it's installed and finished. So it's very important that when you get a drawing like this, you physically go and lay it out and make sure that you've taken into account all the things. We said last week, critical path, think ahead. The windows goes in. As you're putting the window in, what else do you have to think about? Okay, what's the center line between the windows? What's the center line of the room? How do the lights line up in relationship to the windows? Okay. We also talked last week about benchmark. Okay, so for example, you go into a room, you have an elevation on a wall, benchmark at a certain height, okay? You know from this, that's level. You don't know if your floor is level or not. If you measure off the floor and your floor is going like this dimension is going to change depending on where in the floor you go. So you have this, you know the point you're going to set your floor at. You have your elevation, okay? From that, you got your point. You can measure down here, from here down to the countertop. You can measure from here up to the bottom of the upper cabinets. You can measure from here up to your ceiling. And just like you're measuring here up, the electrician is also measuring from here up. Okay? The guy doing the alarm system is measuring from here up. Everything that you're doing, everybody's measuring off the same line. Okay? Other things on shop drawings. If you look on this, it also locates, on that same drawing, you'll see T on the top left-hand side. Okay? That T stands for the transformer that needs to be located within these cabinets so that you can properly prepare for these cabinets while the walls are open. Okay? Everything you do should be on this shop drawing. Everything that's needed by the electrician, everything that's needed by the plumber should be on the shop drawing. And if it's not, you should go back to your supplier, your architect, give him the information he needs so that he can locate the transformers on here. We recently did a job with a company from Italy that gave us all this information, but didn't think it through as to where those transformers were going to sit in relationship to the cabinetry. And in the end, what wound up happening is we wound up taking the walls down again because when they finally came in, they said, oh, that doesn't work. But we put it exactly where it says on the drawing, okay? Again, it's critical path. You have to, when you're doing something, you have to understand, and this goes back to the same theme, why you're doing it. What's the next step? If you're doing it and you're just putting an outlet there, you have to think in your head, all right, I'm putting an outlet there. Once the cabinet's in, how's he going to get into it? Is it going to be accessible? Does it work in relationship to real life? Okay? Excuse me. So these are just two examples of what we were talking about last week. I'm not saying the architect's drawings or the designer's drawings are wrong. They're not. But they're made in a generic application until selections are made. And you have to make sure that once these are done, they work. There's nothing that says you can't take this shop drawing and mark it up. These drawings all get sent to the architect or the designer or the owner, whoever on your job is approving these. They are not going to approve the dimensions. You have to approve the dimensions. They can come in and say it's supposed to be a wood finish or a glazed finish or a painted finish. That's them. As far as this thing fitting, that's you. Okay, so you have to look at this from the point of view of, I'm going to install this. Is this going to work? Everybody understand that? Okay, so that goes back to plumbing. Can you get plumbing there? Can you get drains there? Where it shows transformers, can you put transformers there? Can you put blocking in the way this is framed and still have room in the wall to put plumbing down the wall? It happens a lot when you're doing bathrooms, when you're doing laundry rooms, because you have vent stacks going through the walls, which really reduces the amount of room you have in a wall for piping. All this is important. Now, like I said, we made an adjustment on this to one of the walls. You have to think globally. If you change that one wall, what does it do to the room on the other side? What does it do to the window in the next room? If that room is centered on that window and you change this wall, are you now throwing that room out of center? So I like to look at this as a file cabinet. When you start the job, you have one file cabinet for the whole job. And as you put the shell up, now you have 3 drawers, 1 for each floor. And then as you start going, each room has its own folder. Okay? It starts getting into small sections. And this job like this, rather than being one big project, you have to start looking at it as individual rooms, each as their own project. And if you change something in one room, what does it do to the room adjacent to it? Everybody understand that? Okay? This is the global thinking we've been talking about. This is the critical path we've been talking about. You have to build this thing in your head and know what comes next. Anybody have any questions on that? Okay. So shop drawings are made by the fabricator or by the shop. They're sent in. They have to be approved and signed off. Once they're signed off, they're Bible. Okay, this stuff goes into fabrication. If you haven't done your due diligence to make sure this is going to work, then you have to deal with what you get, and that becomes a problem. There's nothing that says when you get this shop drawing that we should not, as a team, go through this and make sure this fits. Okay? I like to put a story pole. I always call it a story pole on the wall. And basically, you're laying out the cabinets on the wall. You're marking it going across. And you're physically laying it out either on the wall or the floor. And in doing that, you're laying out your cabinets and everybody else is looking at the same marks. Remember that you're not working individually here. You're working as part of a team. So whatever the layout you do, everybody else is going to be using the same layout. If not, what's going to happen is you're going to say the cabinet ends here. They're going to say the cabinet ends here. When they're going to put the plumbing in, it's not going to work. Okay? You're part of a team. Make sure that when you look at this, you look at this as a team. Individually, to make sure everything's going to fit, make your own corrections. And then as a team, to make sure that if any of the subs have an issue, they address it with you before this goes for approval. Everybody got that? Any questions about that? Okay. Also, last week we talked a little bit about how everything is laid out on the plan. And we showed you on the plan when we went to the window schedule, it said like Mark M, Mark Z, whatever the window is noted. When you get a proposal from a window contractor, it will give you a broken down proposal, which will say Mark B, in this case, is velocity impact window 106 by 44. This is not necessarily correct. When we did this job, this particular job, we went through the layouts and we found that what was on the window schedule did not match what was on the elevations. If we had ordered the doors and windows simply as noted on the schedule, they wouldn't have fit. Okay? It's important that when you get this and when you get the shop drawings, you look at them for what's here. Look at the structural drawings to make sure your openings are correct. Okay? Look at everything to make sure everything works together. This is a big puzzle. And very rarely does anybody correlate them except us. Okay? All right. We talked last week about plumbing fixtures, things like that. You're going to get some things from the designer, which you'll be working with on these projects. Okay? You'll be getting a spec book, similar to this. Okay? A spec book will list what the codes are that they're referencing on their elevations. For example, if you're looking at slabs, it will tell you SL-202, which is what's listed on the elevation, is going to be in the theater bar. It gives you the location. It's going to tell you it's in the theater bar. It's going to tell you what the finish is. In this case, it's quartzite. And it's going to tell you where you can get it. In this case, you can get it at cobblestone. Okay? This is your Bible in relation to this. Okay? This is so you know what's supposed to happen. It will also have sections on woods. So, for example, in cabinetry, you will get a mark on the elevation that says, this is W1, just for a number. W1 may be clear maple. Okay, W2 may be oak. It'll be listed in here. So when you get a shop drawing from the cabinet company that says what the finishes are, it's going to directly relate to the finishes noted in this spec book. Okay? Everybody understand that? This is one step from the plan, because the plan gives you the spec. You look in a book, you find out what it is, and then the manufacturer has to look at this and make sure it's in the drawing. You have to go back and make sure this matches this matches the site, this matches the electrical plan, this matches the plumbing plan. Okay? This isn't just a drawing of some pretty cabinets. Everybody got that? Okay. In addition, you'll get a spec book with plumbing. And you'll get a spec book with electric, okay? The spec book with plumbing is going to give you what is in every room. Okay, now why is this important? Okay. Let's just use an example of a toilet, okay? Toilet usual setback off the wall is 12 inches. Some toilets are 10 inches. Some of them are rear discharge toilets, okay, meaning it comes out the back, okay? If you don't know what toilet you're putting in, you don't know where the plumber has to set the drain. Okay? Some of these, if you look, for example, a Toto like Neorest. Okay? If you've ever worked on a site, usually the masters have the toilets with the separate controls, and when you push the button, the lights go on and it plays music and all this kind of fun stuff, right? Right? Those toilets have a different setback. Those toilets require an electrical outlet. And as a location, it has to be in relationship to the center of the toilet on the back. Okay? If you didn't have this, and you didn't know what this was, you wouldn't be able to tell the electrician to put it there. If you did, you wouldn't be able to tell them where. Okay? These have a very specific location where the water supply has to be. If you don't have this, you don't know that.
So the other thing to correlate is you got another wall schedule at that point. It's not just look at that or you'll be messed up on the other end.
Yeah, this is a big puzzle, okay? This doesn't necessarily mean everything drawn is going to work perfect, okay? Sometimes you get a shower body, and the shower bodies will be listed here, right? And in some cases, the walls aren't thick enough to hold the shower body. Or there's a relationship of where the shower body has to be in relationship to the face so that the cap fits on right. So you have to now look and say, here's the front of the wall, I have cement board, then I have stone, so my distance off of this wall is going to be X. That will let you locate it within the wall. With that, you have to go back to your spec book and see what's going on the wall. And if need be, you have to make a call to your tile or slab contractor and say, how much do I hold off my finish for this? Okay? These are very important, okay? Most designers will not, at first glance, give you the location of where a lot of these go. A lot of these require you going back to the designer to say, how do you want these located? For example, you have a shower, okay? You've got a volume control, you've got a pressure, thermostatic control, you've got a diverter. Where do you want them? How high? How far apart? Last job we did, we got a drawing that said where they wanted them. The way they were built, you couldn't put them that close together because when you butted them next to each other, they were further apart than they want, okay? Designers tend to do what looks beautiful on a piece of paper. They look at the handle, they say the handle should be 5 inches apart, just for a number. When you put the different devices together, they may be 6 inches apart. You have to go back to the designer, you have to make sure you have an understanding of they do of what's required. Last week we said never go to the designer or to anybody with a question unless you have a resolution and you have the reasons why you want to do it the way you want to do it. By giving them an answer, I can't do 5 inches, I can do 6 inches. This job, we actually built the assembly on the ground, took a picture and sent it to them. Okay? From that, we said, I can put it here, I can put them this far apart, I can do this. Okay? In doing that, I get an answer. I get an approval on a sketch, I get some response. If I just say they don't fit, what do you want me to do? I'm going to get something back that's crazy. You all know it, right? Okay, so spec book does a few things. One, it lets you think ahead. It gives the plumber what he needs. As far as lighting goes, it's the same thing with lighting. If you have a fixture book, it'll tell him how heavy the fixture is. Does it need to be supported? Okay, what kind of framing do I have to put in? How much clearance do I need? Okay, all these things are required so that you can properly prepare for what you have. In the same token, the same reason you have a plumbing spec book, you also have an appliance spec book. And usually they'll send you the appliance cuts with them. The appliance cuts will tell you how much room you need behind for an outlet. It'll tell you where the drain feed needs to be in relation to the opening. It'll tell you where the water supply has to be. In some cases, you know, it's not as apparent as it seems. Okay? They're not going to tell you what you need per code. So for example, you need an accessible water shutoff for a washer dryer. Meaning you can't, by code, you can't have it so you pull the washer dryer out and the turn-off's over there. It has to be somewhere accessible. No drawing here is going to tell you that. Okay? This is your responsibility and the responsibility of the plumber to know that. Okay? Anybody who's been doing this for a while knows that when the inspector comes in, he's going to say to you, show me where your shutoff is. Okay? And I really recommend that someone note it on a plan because a year from now, when someone goes in there, they're not going to remember where the shutoffs are. Okay? Owners may have an issue with that because they don't want to see it. Doesn't matter. Code requires you have it, you do it. This will tell you venting. This will tell you everything you need. It's important that you have all this information before you start. Okay? Last week, Dan was asking about layout. You have them lay out the entire job on the floor. When you lay out the job on the floor and you go back, you will see if the window's off. You will see if the center line's not right. You will see if there's not enough room for a piece of plumbing. Whenever I do this, I always say, let's lay the entire job out. Everybody knows that around here we put a pressure-treated plate down on the ground before we frame, okay? Before you put that plate down, before you do anything permanent, you lay it out, okay? You make sure everything works. You take your shop drawings, and even if you don't have a shop drawing, you know that window's supposed to be centered on the room. You can check framing to framing. If these haven't been developed yet, then you can work with the contractor who's doing these to make sure it winds up center to center. What I always say is have them put the framing down. Then have the plumber go around with a can of paint. He has green, just for a number. Let him mark where he needs his core holes. Let him mark where he's going to go through that to bring a pipe from below. Let the electrician mark his. Let the HVAC contractor mark his. If you do all this work ahead of time, when you go to install this, it will work. If you don't do this ahead of time, the plumber's going to come to you without a doubt and say, you got a 4-inch wall, I have a 6-inch hole to be drilled. It's not going to fit. That doesn't help if you've already framed the entire thing out. Because in making that wall 6 inches, now you're affecting the center line of the room, and it's a ricochet effect, okay? You're part of a team on the job, okay? You're not the sole body, okay? You have electricians, you have plumbers, you have all these people working with you. You have to make sure you coordinate with all these people before you go to the next step, okay? Laying this stuff out, and I'm not just saying the floors, lay out the ceilings. Make sure you have room within the ceiling for ductwork. Standard piece on these drawings, whenever you're doing soft truck, you always have to add an inch to the dimensions they give you all around because it's insulated. So the job that we just talked about, the architect had a ceiling of 12 feet or 11, whatever it was. The bottom of the beam was at 1110. And then it had ductwork running underneath it, okay? You can't just put a ceiling where they say it is. You have to look at it and say, will this work? And that brings up your questions. Okay, if this doesn't work because there's a pipe there, how do I resolve it? What resolution can I give to the team that's going to work? Okay? At this job, we had a long drain that had to run across the ceiling and underneath the beam. We wound up adding another line down to the basement or the garage to tie into the main drain line and diverted the pipe from going underneath that beam. That let us pick the ceiling up. You don't know that until you lay the entire thing out. That means not just lay out the floor. It means check your ceiling heights. It means looking at the drawing with the plumber, let him tell you where he's going to go. The important thing is that this is a puzzle. It's a puzzle that's not just one facet. It's got multifaceted. It's got plumber, electrician, ductwork. It's got things you might not even think about, like vacuum lines for a vacuum system. All those things are part of the puzzle. And it's up to you to go through and make sure those parts fit. And whatever modifications we have to do it earlier. I've said it before, it's much easier to correct something on paper than it is once you have the walls up. Once you have the walls up, now it's a big demo thing and you have to look at the ricochet effects of what you're doing. When it's paper, it's easy. Change it, move it over, everybody agrees, you go. Okay? Everybody understand that? Okay. So, key points for this week are this. Make sure you have all the information you need. Make sure you have a spec book. Make sure you have selections on appliances, plumbing, electrical, lighting. One of the common things we have going on now is some fixtures are 0 to 10 volt, which means when you're running wiring, you need to add another line or it won't dim properly. One of the common things is that the designers don't know that. So you tell them while you're wiring, I need to know what fixtures are 0 to 10 volts. And then you wind up getting on the phone with the supplier because the designer has no clue what you're talking about. Okay? Unfortunately, you have to be the orchestra leader in a band where everybody's in a different union, okay? It's pretty much the way it is, okay? This is all doable. This is a lot of fun, okay? But it does require a total commitment on everybody working here to work as a team, okay? Every week when I have a meeting, I always ask the same questions. Who has questions of what they need? What do you need to get done so he can continue? You're a team. This has to be thought of that way. Okay? All right, it's half hour, let's wrap it up and go to our meeting. Thanks, guys.